assignments that you're turning into me at the end of the period tomorrow. Wednesday, you're getting a take-home test that's due Thursday. We gotta hop, hop, chop, chop. All right, so welcome back. Officially 2 weeks until Thanksgiving break, and a very well-deserved Thanksgiving break for me. I don't know about you all, but I have earned my Thanksgiving break for sure. Okay, grades are final. I got a little pile of papers in my mailbox this morning from people that I spoke to on Friday about, can I have a little bit more time? And I said, absolutely. I am taking no more papers from anybody. Paul, you okay? You look a little 80s back there. Okay, so grades done, locked in. There are no sob stories. You can come, you can cry, you can bribe, you can do whatever you want. All I'll do is laugh at you. Okay. And because there are 5 folks in this period that have not tested yet, and 10 in my other class that have not tested yet, I will not be passing tests back to you today. Okay, it's okay. Jackie, here you go, honey. Okay, the corrections are going to be due Friday for everybody. Anybody who scored 80 or below on the test, I am a little bit worried because this next unit, applications of the derivative, is all about the derivative still. Last unit was building up your skills, introducing all the derivative rules. I can tell you right now, you know all the derivative rules that you need to be successful in Calc AB. Not BC, but AB. You know all the derivative rules that you need. This whole unit is about applying those derivative rules. And I will tell you right now, with all the love in my heart, and I will say this to the kids in Ohio too, this is known as the toughest unit in the course. We are here. This is going to shake the confidence of some of you. No lie, it's going to shake you. And we're going to be okay because I'm really good at the work that I do, but you're going to have to work hard. Okay? The ideas are not going to seem connected at all. The one connection is that everything has to eventually do with the derivative. And I love it. This is application problems. All my future engineers, you're going to be doing application problems all the time. All the time. For all of you who are like, oh, I no longer want to be an engineer, don't let this one unit set you on or set you off a path. Okay, so here's where we are. I'm going to take attendance. You guys are going to get started. The new unit packet, you're on page 5. And here's what you're going to do. There are 4 example problems that you are going to work on with your peers over the course of the next 5 minutes. You don't need me to teach you anything. You already know all these things. Val, can I get you to move over there, Jackie, please? Okay, 5 minutes, 4 problems. Show me what you can do. I want to be a proud papa with all my DeRozier teenagers. Ready, set, go. Adrian, come on. We're on page 5. I said I'm not able to because I have 5 people testing right now and 10 in 4th year. Peers, guys. Right. Look at the folks around you. Right. Please do. Oh, wait. These are all old skills that you have mastered. Boy, I wanna pause what's happening here because I just walked around and I saw 6 different people doing the quotient rule for the first problem. The question that I'm asking is, what's the limit as x approaches 2? This is not derivative. If I wanted derivative, I would use a different notation. It would look something like that, or it would look something like that. So let's get everybody recentered on what the question's asking, not what you think it's asking. And I need to have a conversation with you about some bad notation that I introduced you to. This is rare. Okay, way back in the day when it came to limits, what you guys would tell me to do is plug in. And you would get 4 minus 4 in the bottom, 4 minus 2 minus 2, and you'd get 0 over 0. And we had a special name for this 0 over 0. We called it indeterminate form. This is an indeterminate form. It's one of about 6. This is indeterminate form number 1. Now here's the thing. And I did not know the College Board was changing their position on this. Apparently they did. They do not want to see, and I do not want to see you ever write that a limit is equal to 0 over 0. We are not going to do that. That's not what good mathematicians do. In the event that you're getting 0 over 0 in an indeterminate form, what you're going to have to do is maybe just kind of jot that off on the side. Don't let them actually see it. In your head, you know it's 0 over 0. And now we're going to come back and say, okay, well, what could we do? What are we really supposed to do here to evaluate this limit? We could factor x squared minus 2x. I can factor out the x to get x minus 2. In the denominator, I can factor again. What do we get?
X minus 2.
X minus 2 and x plus 1. And good news, the x minus 2's cancel out. We take the limit as x approaches 2 and we get 2/3. That's what I was looking for from all of you all. Not a quotient rule, not a derivative. This has nothing to do with derivatives yet.
Oh no.
Yet. Okay, show me what you can do with the second one. Take a derivative and watch me kick it in the head.
Instead of this, you do that. Talking about. Yeah, I'm talking about. Yeah, you multiply. Instead of the -2.
Ah, now I see some people moving in the right direction.
Oh yeah, it is.
Right, if you plug in, you are going to get square root of 4 minus 2 over 0, which is 0 over 0. No bueno. Don't like that, so what do we do? You want to factor? I don't know how to factor anything here. You want to play around with that fancy one. You want to multiply by the conjugate is the word. So we take limit as x approaches 0, square root of x plus 4 minus 2 over x, and the conjugate is the square root of x plus 4 plus 2. In the denominator, square root of x plus 4 plus 2. And that's legal. I heard from Daisy and lots of other friends up front. That's just fancy 1. Is this you okay with that? All right. When I multiply out the numerator, square root of x plus 4 minus 2 times square root of x plus 4 plus 2. Do the box if you need to. But what happens when you multiply by the conjugate? The square root of x plus 4 multiplies the square root of x plus 4, and we get? You get x plus 4. Technically, you'd then multiply square root of x plus 4 with 2. You'd multiply -2 with square root of x plus 4, and what happens? They always cancel out. We don't even bother doing it. We've done this so much. The -2 to the +2?
-4.
-4. In the denominator, we've got x times square root of x plus 4 plus 2. Okay? What's left?
Oh.
Karina, what's left?
Well, you subtract the 4, so you get x, and then you
The
just...
plus 4 and the minus 4, those are going to cancel each other out. And now that x with this x down here, it's all multiplication. Those cancel. And so we're going to get limit as x approaches 0, 1 over the square root of x plus 4 plus 2. And if all goes well, I think you get 1/4. This is meant to be a review, as you know. Henry.
What did you just do there? You just canceled everything out.
In the numerator, I had x plus 4 minus 4. Positive 4, negative 4, 0. X in the numerator, x is a factor in the denominator, those cancel. Okay? All right, see what you can do at number 3. 3 and 4 I'm going to have to whisper about because those kids over there are listening. Or they should be.
Oh, yeah.
Okay, friends up front, 21 minutes.
Cos x.
Everybody seems to have recognized this is 0 over 0 again. I haven't seen anybody figure out what you're supposed to do with this.
And then it's negative. No.
Multiplied by the conjugate.
Oh, I see.
There's a question that I'm asking here that I don't think anybody sees yet. Limit as x approaches pi over 3, cosine of x minus cosine of pi over 3 divided by x minus pi over 3. This is a form that I was hoping somebody was going to recognize. Jackie.
Is it just cos?
It's not just cos. There's a specific thing that I'm hoping you're going to see here. It's not a chain rule, no.
Is it in the tangent line?
This is what?
Tangent?
This is slope of tangent line. Slope of tangent line to cosine of x at pi over 3. And for those of you that are like, what? What the heck is this? Way back in the day, before there were derivative rules, we worked with this expression a lot. F of x minus f of a over x minus a. The limit as x approaches a. Do a little pattern matching here. Does everybody see these are the same? Right. This is the generic form. This is a specific version of this. When I wrote limit as x approaches a, f of x minus f of a over x minus a, what this meant was the derivative. It meant go find the derivative of f at a. So in this case, what this notation is saying is go find the derivative. Finally, you want to find the derivative. What's the function? The function f of x minus f of a over x minus a. The function is cosine of x. We're going to evaluate it at pi over 3. So we need derivative of cosine of x.
Negative sine.
Negative sine of x. And you need to plug in pi over 3. So this is negative sine of pi over 3, which is negative square root of 3 over 2. I knew 3 was going to be tricky, but it's a review. As is the next one. Your life is about to get really good.
So you
Just worse. Like my favorite. Isn't it e to 2x,
Oh, I'm hearing the good conversations now.
Oh,
And
yeah.
remember when the denominator?
What's in the denominator bigger?
Denominator is bigger than 0.
So it's approaches 0.
I'm hearing it now. If I was going to classify this problem, this is a relative growth rate question.
No, it approaches infinity.
You're taking the limit as x approaches infinity of two different functions. The top one is exponential.
Yeah, 'cause look.
The bottom one's a polynomial. There's something that you need to know. I think Jeanette sees it. Marilyn just saw it. Which one grows faster?
B. Oh yeah.
You've got an exponential
Yeah.
compared to a polynomial. Which one grows faster?
Exponential.
The exponential always wins. Always, always, always. So what's the limit? This guy grows faster. If the numerator grows faster than the bottom does, the fraction's getting bigger in the top faster. What's the limit?
Infinity.
Infinity. Okay. This is where we were back in Unit 1 a long time ago in a galaxy far away, before Harvey, before all those things happened. Should I get a question?
How would we use this and apply to like real world?
Real world, who cares about that stuff? No, real world is coming. Trust me, you're not ready for the real world yet. It's coming. All right, now it's time for the push. Our first tool.
Yeah.
Oh, it's going to make your life so good.
Yeah.
All right. Let me erase all this beautiful mathematics. All four of these problems that we just looked at had something in common. They were all limit questions, right? They were all limit questions that resulted in an indeterminate form. Right now you guys know of two indeterminate forms. One of them is 0 over 0, the other? 0 over 0 is an indeterminate form. The other one that you know?
Infinity.
Infinity over infinity. Those are two indeterminate forms that you are currently aware of. There are more. I want to introduce you to my friend L'Hôpital. Say that with me.
L'Hôpital.
L'Hôpital, dead Frenchman. One more time, how do you say it? L'Hôpital. It looks like La Hospital. It does look like La Hospital, I understand, but L'Hôpital, and we will say it that way, L'Hôpital. L'Hôpital's rule is used when you are working with limits and you get an indeterminate form. Your life is going to be mind-blowingly easy, Adrian. Stay with me. Okay. I'll read L'Hôpital's rule to you, and then we're going to look at L'Hôpital's rule. Okay. If f of x and g of x are differentiable just means derivative exists. Hi, friend.
Hi.
What can I do for you? Already? Okay, it's nice to see you. Okay, differentiable means the derivative exists. You have two functions, they're differentiable on an open interval AB containing C. Don't worry about that too terribly much. If you're doing a limit as x approaches C of these two differentiable functions, and you get an indeterminate form, 0 over 0 or infinity over infinity, then L'Hôpital's rule says, and we're not even going to prove it, sad news, that if you want to find the limit as x approaches C of f of x over g of x, you will get the same answer as taking the limit as x approaches C of f prime of x over g of x. What L'Hôpital says, if you have differentiable functions in an open interval containing C, then if you take the limit of this rational function and you get an indeterminate form, the answer will be the same as if you take the limit of the derivatives. Okay? I want to put a little note though, that this guy over here is not, please write this down, this is not the quotient rule. It is not a new version of the quotient rule. This is, what was the name again? L'Hôpital's rule. Thank you, you culturally diverse students, in saying the French correctly. L'Hôpital, that's kind of Italian. Okay, so I want to look at this example 1 again, which you guys struggled mightily with and I was not expecting. Limit as x approaches 2 of x squared minus 2x over x squared minus x minus 2. Can we use L'Hôpital's rule here?
C.
In order to use, excellent answer, Jackie, maybe. If I'm going to use L'Hôpital's rule, number 1, are the functions, are the f and the g differentiable? Do their derivatives exist?
Yes.
Probably.
Oh, yes, sir.
Okay? The next thing, though, is you need to check the limit as x approaches 2 of the top. And separately from that, this is the new thing, makes me go, oh, God, I didn't have to do that in high school. You check the limits separately. Stay with me, Adele. Limit as x approaches 2 of x squared minus 2x. What is that limit? 0. Bottom? 0. Will this give you an indeterminate form? Yes. So, by L'Hôpital, we're just going to write by LOSP. That limit is equal to the limit as x approaches 2. You find the derivative in the top. You find the derivative in the bottom. Derivative in the top, 2x minus 2. Derivative in the bottom, 2x minus 1. Derivative in the top, derivative in the bottom. Now evaluate the limit. As x approaches 2, limit as x approaches 2 of 2x minus 2 is 2. In the bottom?
3. Oh my god.
Bam! Done! What? Sorry, I missed my 9-year-old already.
Same.
You know.
And that's what I'm asking.
Yeah.
If you do it normally, you still get a 3.
Oh my God, Eval, say that one more time.
If you do it normally, wouldn't you get 2/3?
Okay, I just asked you to repeat it. I didn't ask you to shout at me. Okay. If you did this normally, do you mean like factor, cancel, all the things? Of course you're going to get the same thing. It's the same math problem that you're solving, you're just going a different route. Okay? Okay, so let's try this next one. You want to use L'Hôpital, but you have to check your conditions first. Okay, are we going to get an indeterminate form?
Yeah.
I think so, right?
Yes.
Okay, but you have to show it. Limit as x approaches 0, square root of x plus 4 minus 2. Limit as x approaches 0 of x. Check your top. 0, check your bottom. 0. They both go to 0. So what does L'Hôpital say?
By L'Hôpital.
By L'Hôpital.
Limit as x approaches 0.
Limit as x approaches 0. Be careful. Derivative of the top.
1 over 2 square root of x plus 1.
Oh, Daisy, it was like angels singing to me. 1 over 2 times the square root of x plus 4, because we're taking the derivative square root of stuff. Minus the derivative of 2? 0. In the denominator, take the derivative of x.
1.
1. Evaluate the limit. You're going to get 1 over 2 times the square root of 0 plus 4. 1/4. Should not be surprised, Garrison. It's 1/4. We knew it was 1/4 already, Abel, right? That using that usual way. But now I don't need to worry about things like multiplying by the conjugate. If I see 0 over 0, we're good to go. Karina.
So if it wasn't 0 over 0, we don't use that.
If you aren't getting an indeterminate form, 0 over 0, infinity over infinity, don't use L'Hôpital.
Then how do you get infinity over infinity?
You'll see. Paul.
When are we going to learn the other indeterminate?
You in about 8 minutes. Okay, see what you can do the next one. Although they might all be on the page labels, L'Hôpital's rule. Marilyn, make sure that you can use L'Hôpital's rule. Some of you guys like to use your new tools even when you're not supposed to.
Oh.
Oh, for this one? It's asking for the derivative. So,
They made add. You gotta make sure that it's 0 for 0. It's 0. Okay.
Tester, 7.5 minutes. Yes.
wait.
Ah.
We'll talk about that.
But we already did that. Like, we're using the new rules.
Right. We already looked at this one.
Yeah, but it's close to 0.
You know it's going to be 0 over 0. Don't hulk out on me, Paul.
Yeah, you can't use it.
If I take limit as x approaches pi over 3, cosine of x minus cosine of pi over 3 is cosine of pi over 3 minus cosine of pi over 3. Guess what?
0.
0. Check the limit in the denominator of x minus pi over 3. You get pi over 3 minus pi over 3. You get 0. Good news. You get to use L'Hopital. By L'Hopital. And this one you guys struggled on mightily earlier because nobody saw this as a derivative question. Nobody saw it. Well, what does L'Hopital say?
By L'Hopital.
By L'Hopital, limit as x approaches pi over 3.
Equals negative.
What happens in the numerator?
Negative sine of x.
Negative sine of x minus
Plus sign of it.
Times X.
It's not.
Times
It's
X.
nothing because isn't that a number?
cosine of pi over 3 is a constant. So the derivative of cosine of pi over 3 is 0. Go to the denominator. 1. Take that limit, you get negative sine of pi over 3, which is negative square root of 3 over 2.
Oh, that's crazy, Mr. Deroji.
All right, last one, and then we're going to break up.
You are
Not like forever.
You are my spirit.
I tried. Okay. Oh, and we got to change this to a plus sign here. My bad. Okay. Limit as x approaches infinity, e to the 2x plus x, x to the 4th plus 3x squared. I'm going to check them separately. Limit as x approaches infinity, e to the 2x plus x, that is infinity. Limit as x approaches infinity in the bottom. That's infinity. So we have infinity over infinity, which means you get to use L'Hopital. Limit x approaches infinity. Let's do it. Derivative in the top. You've got all these newfound derivative skills. Derivative of e to the 2x. Or e to the power of 2x. E to the 2x times 2 plus the derivative of x, which is 1. Go to the bottom. Derivative in the bottom, 4x cubed plus 6x. Take that limit.
Hey. Because the top is going
I
fast.
didn't really change.
If you take the limit, limit as x approaches infinity of e to the 2x times 2 plus 1 is infinity. Limit as x approaches infinity of 4x cubed plus 6x is infinity.
I don't understand.
So guess what?
Do it again.
It didn't work.
Hold on, I didn't say that.
I thought because it is.
We used L'Hopital's rule, and it was okay because we had an indeterminate form of infinity over infinity. But L'Hopital's rule led us to a new rational expression, and we're getting infinity over infinity. Trust your instincts here.
Give up.
Don't give up. You're DeRozier's. Can we use L'Hopital's rule again?
See,
Absolutely so by L'Hopital.
oh, we find it. That'll be fun.
Limit as x approaches infinity. Find the derivative of this guy now. which is e to the 2x times 2 times 2 again in the denominator, 12x squared plus 6. Oh gosh, what's going to happen here?
It's going to be the same.
Infinity. Infinity.
So where did you get that that times 2 from?
Chain rule.
Oh,
This first one's from the chain rule. That one's the 2 I was multiplying by before. So guess what? Limit as x approaches infinity, e to the 2x times 2 is infinity. Limit as x approaches infinity, 12x squared plus 6. It is infinity. Now some of you are like, it's not getting any better.
It will.
It will.
Does anybody see how it's actually getting better?
Yeah.
Gonzalo, what's changing in this process?
The denominator.
The denominator is changing. The degrees are reducing. Okay? In the numerator, it's not reducing. In the denominator, it is. Eval.
Is there a way to symbolize how many L hopes you're doing? Like the second one you put L'Hopital, do you put L'Hopital 2?
Nope. Just by L'Hopital again. Okay, so let's do it. By L'Hopital. Limit x approaches infinity. Get the denominator, derivative. E to the 2x times 2 times 2 times 2. Denominator. 24x. Dang. Another one. Okay. I'm gonna get a little sloppy here. Let's just do another see what you did to me.
Let's get sloppy.
Limit x approaches infinity, e to the 2x times 2 times 2 times 2 times 2 in the denominator. 24.
Oh my God.
My friends, we have arrived.
How do you know what?
The numerator goes to infinity. The denominator, 24. Take infinity and divide it by 24. Infinity. For the 4th time in a row, the exact same answer that we had if we knew other things. The nice thing is 4 problems in a row, because we had an indeterminate form, L'Hopital's rule solved all of them. Every single one of them. Without, oh, here it's multiplied by conjugate, here it's the derivative, here it's relative growth rates. L'Hopital's rule is like your one new power tool. Yes. Everybody good?
See.
Henry.
But you can't tell it's infinity because the limit is going from x to infinity, and then e to the 2x was on top, and then x to the 4th was the bottom.
Completely agree with you. If you recognize relative growth rates, oh my God, that's the best way to go about doing this. Absolute best way to go about doing this. Are we good? Okay, so you guys are done with multiple choice. Moving on to the free response. Enjoy the ride. I can't wait to score your papers. Keep going. Okay, friends over here, it's time to split the group.
Oh no.
You know enough. Stay with me, stay with me. You know enough about L'Hopital's rule for calculus AB. To be successful on the unit test that is a couple of weeks from now and the quiz that is next week, you know all the things that you need to know. However, I think some of you want more. You're hungry for more, and I want to feed you the more. So you get it. Here's where you're going to choose. Group number 1, the folks that are like, no, coach, I'm good. I'm good. I'd like to start on the homework. The homework for everybody is it's assignment. It's assignment for lesson 51. It's on page 57, 58, and 59. It's 12 multiple choice questions. They're all multiple choice. Some of them, L'Hopital's rule will be a good thing for you to use. Some of them, L'Hopital's rule will not work for you because it only works if you have an indeterminate form.
Yes, sir.
Those of you that want to get started on the homework, I'm going to move you to one side of the room. Those of you that are hungry for more, I want you guys to move up front, and there's 5 more indeterminate forms and some problems that we're going to play around with. So where are the folks that are hungry for more? Karina, Paul, Yvel, Henry.
No, I take it back.
Why don't you guys move over here? Everybody else, move to the back. If you're in the back, you're working on
I
homework.
take it back.
No, you don't. You're over here, Karina. And Gerson, yep, I think I saw your hand. And Gonzalo and Rubio, yeah. Oh, and Marilyn too, yep. What? They're over on this side of the room because they're hungry. Okay, Jackie's working on the homework.
What was that? Sorry, what's your name now?
All right, so I've got Marilyn Evel, Paul Gonzalo, Henry Karina, Daisy.
Christopher.
It's not that I don't want you to do this, but I think working on the homework is the right path for you. Working the homework, son. Okay, Jackie, get working. Adrian, I need you to be the anchor over there. Okay, whatever that means. Okay, so this is actually a BC lesson. I'm on page 9.
Oh.
Okay, that's okay.
It's spicy.
This will not hurt you at all. It can't possibly hurt you at all.
Can I help you?
Of course. Okay, moving on. So, if this was an AB class, there's only 2 indeterminate forms we talked about. 0 over 0 and infinity over infinity, and L'Hopital's rule takes care of all. Here are some other forms that we don't know what to do with mathematically. Infinity times 0 is a problem for us.
Zero.
Why? I heard Paul say right away, why is this a problem? The answer is 0. Not always. Aren't there some rules out there in mathematics that say a number times 0 is 0? But aren't there some other rules out there that say like infinity times a number is infinity? Which one wins? We don't know. Here's another one. Infinity minus infinity. What might some people think this is?
0.
0. What might some other people think it is? Infinity. Other people might think?
Negative.
Negative infinity. The 0 people are like, well, a number minus itself is 0. Other people say infinity minus a number is infinity. Other people say a number minus infinity is negative infinity. Who's right? Who knows? These are indeterminate forms. Stay with me. Here's another one. Infinity to the power of 0.
1.
Some people say 1. They're wrong. Okay. 1 to the power of infinity.
That's a hard one.
That's 1.
Is it 1? Is it infinity? Who knows? Okay. 0 to the power of infinity. Maybe it's 0. And then there's another one I can't remember right now. Let's just call that a mystery.
Over what?
It happens sometimes, Mr. Harper. Hi, Jackie. Don't you have homework to be working on? No, because that would involve you taking your phone out. Do that like in the bathroom, where no one will see. Okay, moving on. So these are other indeterminate forms. L'Hopital's rule, however, only works if you have a fraction of the form 0 over 0, infinity over infinity. Ah, there it is. Thank God for my new word wall. 0 to the 0. Not to be confused with 0 degrees. 0 to the 0 might be 1, might be 0, who knows? Exhibit A of Shake Your Brain. I want to find the limit as x approaches infinity of e to the negative x times the square root of x. Why is this going to be a problem for us? Henry, what do you see?
E to the negative infinity.
Okay, limit as x approaches infinity, e to the negative x. What does that graph look like? Decreases, right? So e to the negative x, that limit is 0. What about the square root of x?
Infinity?
That's an infinity, right?
Yes.
0 times infinity is a problem child for us.
Oh.
We want to use L'Hopital's rule, but we can't. L'Hopital's rule works if you have fractions. 0 over 0, infinity divided by infinity. If only there was some clever thing that I could do here that would allow me to use L'Hopital's rule. Yvel, what do you see?
Can you put E at the bottom to make
Is that legal? Is it legal to rewrite this problem as square root of x over e to the x? Is it better?
Yes.
Why? Now you can use, but I gotta be convinced. Limit as x approaches infinity, square root of x, what is that? Infinity. Limit as x approaches infinity, e to the x, what is that?
Infinity.
Infinity. This is good. Here, no l'hopital. Over here, l'hopital. So, by Lahas, go get it. Limit as x approaches infinity. Derivative of the square root of x. 1 over 2 square roots of x. Derivative in the denominator. E to the x. It's there.
1 over E to the square root of x?
Limit as x approaches infinity, 1 over 2 square roots of x. This whole part here approaches 0. In the denominator, approaches infinity. That is not an indeterminate form. This is a form that you know the answer to.
0.
Why?
Because anything divided by 0 is 0.
I like what you said, I don't love what you said. I heard anything divided by 0 is 0. You get your divide by in the wrong order. 0 is being divided by a number.
Oh yeah.
Your numerator's getting smaller, the denominator's getting bigger. What's the whole thing going to be? 0. Okay? The key here was it was not l'hopital ready, but we did a little bit of rewriting with some algebra, and it became l'hopital ready. And that was all the difference. Okay, so you guys can do the second one. I'm going to do a quick lap. Alright, limit as x approaches 1 from the right. What happens with natural log of x? That's a graph you guys should know. Graph of the natural log of x looks like that. It has a root at 1, 0. As x approaches 1 from the right, we're getting close to 0. 1 divided by getting close to 0 is infinity. Minus what's happening over here. 1 over x minus 1. Your x gets close to 1, you get 1 over 0, which is infinity. Uh-oh. One of our new indeterminate forms, infinity minus infinity. I need some cleverness here. L'Hopital's rule cannot be used for infinity minus infinity. It can be used for 0 over 0 and infinity over infinity. There's some algebra that you might want to consider here. No, what do you say?
Can you put them together by making the denominators the same? So,
Is that legal
yes.
to get a common denominator and make it into one fraction? Okay, so if I do that, limit as x approaches 1 from the right. 1 over natural log of x minus 1 over x minus 1. I know some of you guys know something called the butterfly method. So you would say 1 times this guy minus 1 times that. X minus 1 minus natural log of x. In the denominator, x minus 1 times the natural log of x. Check the limits. Limit as x approaches 1 from the right. 1. minus 1 minus natural log of 1, 0. In the denominator, limit as x approaches 1 from the right of x minus 1 times natural log of x. X gets close to 1, 0. Natural log of 1, 0. Whole thing multiplies out to give you 0. This is good for us. 0 over 0. Green light. L'Hopital. So try L'Hopital. What does L'Hopital tell you? L'Hopital's rule says come back over here, take the derivative in the top. The derivative in the top, derivative of x is 1, minus 1's a constant, minus 1 over x. Derivative in the bottom, you've got 1 times the natural log of x plus 1 times 1 over x, and if you're not sure what I just did, product rule. Product rule. Oh, wait. Product rule, derivative of the first times the second, plus the first times the derivative of the second. No. Okay. If you finish it off, what you're going to see is 0 in the numerator. And sad news, 0 in the denominator, which means L'Hopital's rule again. Okay, really sad news, it's 9:39. For some reason, bells aren't working. I don't know, that's, I'd say above my pay grade, but not really. Beyond my interest level.